So the next job that I'm doing is actually the first aluminium cylinder head in my gas flowing room, so it's quite exciting to mark that off. And it's a Ford RS Focus, the new shape one. So this is a 2.3 litre EcoBoost engine, I believe. So we're just going to tidy the ports up, get rid of these rough edges in there, match the gaskets, and just make it right, hopefully. All the porting's done on the EcoBoost now for the RS Focus. I'm putting 3-angle seats on it at the minute, so this is the inlet side that I'm doing, then I'll swap the head around and do the exhaust. That then needs a reface. While that's in the wash, I then need to just port his inlet manifold slightly. He's bought this really nice inlet manifold, but I just need to match these edges up slightly. And then the other thing that I can feel is whoever made it, there's quite a groove there where I don't know what they've machined it with, but it's like it's picked up and bounced on these ports. So I'm tempted to remove this, try and mount this and give it a reface, but I'll speak to the owner first to see if he wants to pay to get that done. But I think it needs doing because I can really feel that bit there. So yeah, 3-angling the seats and then a reface. All the seats are cut, all the gasket faces are prepped, so I'm going to reface it now. Let's see how good we can make this pretty bad surface look. So there we go, it's actually really good. I've taken 3/1000ths of an inch off it. Looks really nice. I've deburred it all. So I'm going to stick that in the cleaner now and leave it in there all day. Make sure I keep moving it around so we get in all the nooks and crannies, and then give it a good blowout, and then another final wash in the carbon clean machine that we bought. Then it's assembly, valve clearances, and just check that all the cams turn in it without hitting anything. So it's been in the wash all day. Kept turning it over and rinsing it out. I've then washed it off in the carbon clean machine as well to make sure it's really clean. I'm really happy with the finished porting on it. Looks really good. I'll show you the other side in a minute, but I thought what I would show is the valve. So you can see that I've started to face the valve, and there's literally a little square bit dented into the valve. That's why it's always quite important to reface the valves, because it didn't actually look that bad, that valve. So it's still okay, that'll reface out, but I thought I would just quickly show you what it could be like if you was to not reface it. So I'm going to go and put that one back in, reface it a little bit more, and yeah, then I can start to build this cylinder head. It's running a Piper spring, so the other thing I've got to do is just check that the spring will go in at the right installed height as well. So that's this RS Focus cylinder head 2.3 EcoBoost all done. I've done 3-angle seats, polished the combustion chamber, got rid of all the sort of rough edges in there, reconditioned the valves, and then I've opened up the exhaust port slightly, ported all the way down as far as I can get into the port on all of them, on the exhaust. Then it's been diamond refaced, 4th thou off that. And then this is the inlet side. So I've opened up the inlet to the gasket, ported all the way down to the seat. There's some funny edges in there, I've got rid of all of those. I've then fitted Piper, my customer supplied Piper cams and Piper springs. So I've fitted new valve stem oil seals, Piper springs, and then these Piper 285 cams, and then set the tappets to, the inlet is 10 thou and the exhaust is 12 thou as Piper recommend. And then torqued up all the cam bolts. So this is done. What I'm going to do now is recondition his injectors and test them, and then modify the inlet manifold. But the head's completely finished. Try and get a torch down. So the next thing is these injectors, which are pretty coked up actually. I'm going to change the Teflon seals on it. I don't know if I could change the filters in these. I'll have a look. If I can, we will. So I'm going to load them into the machine and we'll see how they're flowing, give them a clean, and then see how they're flowing again. A 30-second run and they're all absolutely the same. The spray pattern is really good. So I'm just going to run them through the cleaner, put new Teflon seals on them, and then get them fitted into the cylinder head as well. So I've ported the inlet manifold, and what I'm going to do now is just give it a reface, just to sort out where this milling machine, or whatever they've machined this with, has bounced and took some big chunks out of that. It probably wouldn't affect it, the gasket would probably take it up, but I want it perfect, to be fair. I ported it all, I ported all the way through on this, only really to match the ports out. This is actually really good quality. Like, this here is just a bit of tool chatter, but the actual inlet, or the plenum chamber, is a really nice one. It's really good quality. Whoever made it, I should imagine it's this Gradient Engineering, done a nice job finishing it, powder coating it, and yeah, don't let this put you off buying one of these if you was thinking about it. Like I say, the gasket would more than likely take that out, but I just want it perfect. So that's that finished now. It needed 1/8 thou off it to get it true, but really happy with the finish of that. So I'm going to wash that. I'm going to bolt it to the cylinder head loosely and get some photos of it. That's the Focus RS all done. I've loosely bolted this inlet on. I've only put 2 bolts in it because it bolts from inside the plenum chamber as well, but I thought it would just look good for when he comes to collect it. So the spec of that is, it's fully ported, 3-angle valve seats. The valves have been reconditioned, new stem seals, polished the combustion chamber, fitted Piper 285 camshafts to it, Piper valve springs, set the valve clearances to what Piper recommend, which is 10 thou on the inlet and 12 thou on the exhaust. I've taken the Gradient Engineering inlet manifold apart, matched that to the cylinder head, polished it through, only like little bits and bobs. Refaced the manifold face on that manifold because it had some chatter marks from the milling machine when it was made. Very good quality inlet though, so like I said earlier on in the video, if anyone is thinking of buying one of them, I do recommend that. It's good quality. It's just, I think the gasket would have took it up, it's just I wanted it perfect. And then the next job that I'm doing is some Porsche air-cooled 6-cylinder heads. Our customer Matt at Select has got 6 of these that he wants. The valve guides, the exhaust valve guides replacing, and anyone that knows the cylinder heads knows that the guides on these are so tricky to get out. One of the main problems with the guide is the material is dead soft, so when you try and machine or press it out, it just blows the end over. Let me see if I've got any that I've taken out. No, you can't really tell on these. Some people try and drill the center of them like that. Someone's already had a go at this particular one, and the best way I found to do these is to give yourself something tough to press against. So if I was to try and hit this out or press this out, all that would happen is this would just blow out. So what I do with a step drill bit like what's in here, I bore all this away until it's flat. So just with quite a low speed, you don't need it flat, it's so soft. Boring down till I'm on basically the spring seat face, And then with a sharp chisel I just tap off that bit that's left. And then basically when I use my press, I'm pressing against a supported part of the valve guide, so it can't blow out anymore. What I'm also doing is I'm pressing the cylinder head up because I'm pressing against the valve seat, so I've got it really well secured. We'll go with a bang like that, and then that's it. As soon as I hear that, I know that I'm free, and that will press that out and it won't damage the guide socket at all. So if I just get the cylinder head off, and then I'll show you inside the guide socket. So that's the guide fully out, and as you can see there's no snagging on the guide at all. All it's done is just push that out nice and clean. And then in the cylinder head, I don't think the camera will pick it up, but I can see it with my eye. It's really nice and neat in there as well too. So the next job for me to do with this is to press in the new valve guide. So this is the new valve guide. I'm going to measure the OD of this old one, measure the OD of the new one to make sure that I've got the right fit, and then I'm going to make something that pushes this in and leaves the right amount of guide above the spring seat face, which Sam's already measured this and wrote it on one of the heads. It was 12.7 mil. Yeah, I can see it on there, 12.7 mil, which might be that part there, I don't know. But I'll set up and then I'll carry on showing you guys. Well, I've got the guides in the Porsche. I've had to remove these exhaust emissions things that was in there, which was a bit tricky, but they've all come out. I've cut the exhaust seat because it had the new guides in, so they needed doing. And then as I was checking out the inlet seat, it looked like they'd lost their shape a bit, so that's the first inlet seat that I've cut. And yeah, I mean, it was pretty bad. So what I'll do now is show, hopefully this one's out as well, so I'll show the seat being cut here. Don't know if the GoPro's going to pick the footage up, but as I'm bringing the cutter down to the seat, I'm keeping an eye on the seat. Yeah, you can hear it. It's cutting on this side here near the exhaust. And that's it. That seat's now nice and true, so that was the same. It didn't look like the inlets needed doing, but they quite clearly did. So I've got 4 more of these to do, then they're ready for Matt to come and collect. So that's the Porsche heads all done, and what I also did, because the seats was a mess, I thought I'd reface all the valves, and luckily I did, because the inlets weren't too great, to be honest. But they've all refaced up now. So all Matt's got to do now is give them a wash through his parts cleaner, get the Porsche engine back together, and that's another car done. So I've had this little single cylinder motorbike engine come in, which has got a damaged main journal, and it uses this roller bearing. So what I'm going to do is grind this down and then make a steel sleeve and press it on. So I've got to first of all true up the crank in the crank grinder. I've got to lock this con rod in just with tape, insulating tape or masking tape, stop that spinning, and then I'm going to start to grind it. What I grind the OD to isn't that important. I just need to get it where I'm putting a thick enough sleeve on it. So I'm going to take I'm going to get it down where it's flat and then take another mil off, and then I'll press a sleeve on, make it a little bit bigger than the inside diameter of this ball bearing, and then grind it down then to the right size back on the crank grinder. So first job is to level it off and sort this out, and then once I've done that, he's also bought his cylinder in for a rebore, so I'm going to have to clean the top of it and the bottom of it up, and then measure the piston, it's obviously a Suzuki, and get it bored out. So the actual rod isn't moving as much as what I was thinking it was going to, so I'm just going to let that swing actually. So first thing I need to do is switch the subs on. And then you can see that it's grinding the part which is not worn. And I'm just going to go right back into the radius of the main. And then I'm going to take a fairly decent sized cut off it now. Back into the corner. I'm going to keep grinding from the corner or from the radius outwards. It. So I'm going to go one full turn back off here, switch the machine off, and then I'm going to measure the inside diameter of the bearing, the outside diameter of the shaft, and see roughly what size my collar's got to be. And if I feel like it needs a bit more meat to it, then I'll just grind a bit more off there. So this measures to be roughly 18.5 mil. And the inside of the bearing is 20 mil, so it's 1.5 mil, which I'm going to take another 0.5 mil off this, so I've got 1 mil of. So basically, the way it goes at the moment, the sleeve would be 0.75 a side, and I think I want it a bit meatier than that. So I'm going to take another 0.5 mil off this, which will make it 1 mil a side of sleeve, 2 milling in total. So we've got 20 mil inside diameter of the bearing, and an 18 mil outside diameter of the crank main. So I'm going to make a sleeve up now with a 1 mil wall thickness to press it all the way onto the crank. So I've taken some measurements from how I've ground it down, and oops, it's 18 mil on the outside diameter. Well, it's actually 17.98. I found a nice bit of steel for it, which is going to be plenty big enough. So the first thing I'm going to do in the lathe is bore a hole in it. Now I don't want to get it straight to size, so what I'm going to do, I want to bore it out with a boring bar, not with a drill bit. So I'm going to drill it out to 15.25, so 15.25, and then I will finish it off with a small boring bar to get it where I've got roughly about a 3 to 4 thou interference fit. So what I'm going to do now is start to do all my measurements in imperial. For some reason I seem to be able to work better in imperial than I can metric, so I'm going to do everything imperial. So I could do that just by changing the vernier over, but the other thing that I'm going to do is measure it with the micrometer, so I know that I'm really accurate. So the sleeve, this is measuring to be 706 thou. So the sleeve I'll make to like 704, 703, something like that. So like I said, the first thing that I'm going to want to do is get my bit of steel mounted into the lathe. And I need enough sticking out for the distance of the nose of the crank, get it nice and tight. And then this bit here, this step, this is 20 mil, so what I'm probably going to do is just quickly make that all the same, then bosh the drill down it. So I've made the sleeve. Oh, the fucking screen's filthy. So I've made the sleeve, I've machined it down, and I've given it a 1,000ths interference fit for the roller bearing. So that kind of starts to go on, but doesn't press all or push all the way home. I think it needs tapping in. I'm hoping that's right. I haven't, there was nothing good to measure off, so I'm assuming it wouldn't just be a slide-on fit. But yeah, I'm really happy with the repair. It's 1.5 mil thick sleeve. I've drilled in the pin, locking pin hole, I believe that to be, so it's gone into the old hole as well. So I measured out from that flat part of the crank there to the original hole, and then put it back in, and it was in line with the Woodruff key. So I'm hoping that's that done now. I'm going to wait for my customer to come and have a look to make sure he's happy with what I've done. And the last job I've got to do is just rebore his cylinder. So I'm going to set that up on my single cylinder boring stand and get that bored to size. So the motorbike cylinder has been rebored on my SPS mini bar holder. I've had to take 0.5 mil out of that and give it the right clearance, so that fits in there nice now. I've double checked it, it's the right size. Where I've stuck the bore gauge down it puts a tiny little mark in the bore, so I'm just going to blip the honer up and down to get rid of that, put a nice chamfer on it, and that's ready to be collected. So that's the motorbike stuff done. I hope you like the sleeve repair. I was quite happy with that, and we'll move on to another job. So I hope you enjoyed this video, guys, and catch us on the next one. Ta-ra.